Hello everyone, welcome to another coding video with me, Tyler. In this video, I'll be going over my USA and Canada Wildfire Mapping project. On a huge shout out to ProdMap with his tutorial on this. If you want to know more in depth on the stuff I'm talking about, please go over to his channel and watch this video. I'll link it in the description below. But let's get back to my project. In this project, I'll be using Anaconda with Jupyter Notebook using Python 3.9.12. Right here is where I got the data set from. Whenever you download the data set, you're going to be downloading every country's data set. What I did to save space on my system was I just deleted everything that I did not need, which was everything besides the United States and Canada. These are the important import statements that I'll be using. And let's get to the code. The first code is I want to grab all the CSV files from my file, which I called USA Canada Wildfire data. So far there's 62 inside the file, the all list. And now I want to look at just one of them just to save time with floating. So I did one for US and Canada, but I just needed to do the US. As you can see, we have latitude, longitude, byte, scan track, acquired date, acquired time, satellite, instrument, confident version by FRP, day, night, and type. One thing that you can know is that all the confidence score is in string format, which will be a problem later on. Then I looked at the satellite to see if there's more than just one satellite. Then I looked at the instrument to see if there's more than just one instrument. I looked at the data type for it of the confidence is string. And then I looked at if it was a string, it said true. And then I looked at the unique values for it and it was NHL. So there's only string values inside it. I did a heat map correlation map with it to see what correlates with what. And I used a scatter plot. Then I went to the modest data set. Just one of them did the same thing, but as you can see in the confidence score, they're end values. So that's different from the values up here, but it was just string. So then I did the same thing. I looked at the satellite instrument and there's two satellites besides the one, but one instrument. And then I looked at the confidence. It was, like I said, a integer value. Then I looked at all the unique values for it. Then I plotted the heat correlation map, looked at the values between them, and then I used the scatter plot to plot out all the values on the scatter plot. And then here's the most important code in this. I got it from the tutorial I showed you, but here we get rows, fire df, and row sum. For all values and all the CSV files, I df p vcsv for all of them, parse dates as required time, and then low memory false, so I can do it pretty fast. Well, load all of it. And then for the rows, I made it so I would get the path, the name, shape, required date, satellite, instrument version, latitude, longitude, confidence, satellite, and required date, unique values. And then to fix the string values in the confidence score, I replace all the L's as zeros, indicating low, and to 50 indicating normal, and then H to 100, which indicates high. I append all the row right here into rows, which is up here, and then append all the data frame into the fire DF, which is this one right here. Change all of the columns, and then I looked at it. So right here, you can see the path, the CSV, how much rows were in each of the data sets, columns, dot, and this is just the times, satellites, instrument versions, latitude, longitude, confidence, stats and days. And in total, there was 11.5 million rows of data. Then down here, I looked at the fire DF, and then I concatenated it into the US Canada fire DF. Take a sample of 10 of them, and we get latitude, longitude, brightness, scan, track, required date, required time, satellite, instrument, confidence. And as you can see, with these 10s, you see it's kind of fixed. Version, byte, FRP, day-night, byte, day-night type, byte, and not a byte. Then I sort of divided by acquired date and acquired time. Then I looked at all the confidence scores to see if I get all the string values. And it was 101 unique values. I looked at the brightness. The brightness indicates how high the temperature was. Looked at all the unique values for them. Like the satellites, there should be 3, which there are 3. Like the instruments, there should be 2, which are 2. Then looked at the FRP, which is fire radiative power, and it shows me the I guess values from it because it described it. And then type tells me which fire it was, which is one of these types. Then I looked at confidence, low confidence fire, which is B low, so like 0. Normal confidence fire, which is normal, which would be around 50, and high would be about 100. As you can see right here, I looked at all the columns, and then I plotted it. Then right here, I put all the data inside a more correct form. And then there was 300 or 3.3 million data sets. Looked at all the confidence score unique values. Then I only grabbed the values with a confidence score above 50 or 50 or above. And then the final data set is going to have 2.6 million rows. Laid out the confidence score, and then looked at it. So as a final data set, we're gonna have latitude, longitude, required date, satellite, instrument, FRP, type, bright, and confidence. I uploaded the file as this, looked at the dates, and then I looked at the correlation values. Then I wanted to find data only for California in case I wanted to do predictions for wildfire. I just wanted to use California. So that state finds the longitude and latitude for it. So this is what I did. I grabbed all the data from what I just uploaded, which was right here. Then I looked at the shape, but there was only 221,000 values. Looked at 5 samples. Look at the information. All of it looks good, clean. described it, like the type, I saw that date was an object, so I changed it to a date time. And then I grabbed the year and month and then saved it into a CSV file. Now we go to map. I'm using map blocks GL. You would have to go make an account at Mapbox to grab a token. I'm gonna delete this token so you won't be able to use it. You would have to make your own, but these are the input statements you're gonna have to use. Mapblocksgl.utils and mapblocksgl.viz, and I'm importing circle viz, create color stops, df2gl JSON. And then I'm reading both the US and Canada fire and the California fire. Like that, I knew that I had to change the date to an actual date time. So I did this, grab the year and month. Now I call it date time, and now I have year and month. I re-looked at it, which looks like this now. We have to add a year and month to it. We got all the unique values, and then I had to filter it to 1 year because there was too much data whenever I plotted it to actually wanted this PC. So here, let me run this. Give it a second. It's creating the points, which for that one, there was a lot. But now we will see all for the US and Canada. See up here and down here. When you scroll over, it gives you the points for it. And I did it for California. As you can see, there's huge clusters. But if you go over, you can see all of the points. And yeah, that's my project. Thank you for watching.